The American Society of Human Genetics envisions a future where people everywhere realize the benefits of human genetics and genomics research. This year, we are excited to again bring you all the latest science in genetics and genomics, as well as insights on ASHG's diverse programs to unite and engage the community in new ways. This is the ASHG 2021 Virtual Meeting, and you're watching ASHG TV. Hello and welcome back to ASHG TV and the second of 3 daily episodes brought to you from the ASHG 2021 Virtual Meeting. The focus today is on the impact of genetics and genomics on the future of medicine and health.
Personalized or precision medicine is leading us to the verge of a step change in the way in which medical care is designed, targeted, and delivered.
If we really understand why is this patient getting sick? Why is this patient having heart failure? And we understand at a genetic basis, we are much more enabled to find the targets of these.
The need for better drugs is worldwide. Better drug targets are the master key to new medicines in areas of unmet medical need.
When it comes to human genomics, it's really important to recognize the rich culture and history our indigenous populations have around DNA.
We're treating a lot more of diseases that are heard of and those that are unknown because we're now being able to have that diversity of inclusion.
First, let's hear from Kenneth Ramos, the incoming chair of Public Education and Awareness Committee at ASHG, about the benefits of genetics to public health and the potential of genomics-driven precision medicine.
Genetics and genomics actually has been a major catalyst to advances in what we now call the field of precision medicine. Society right now is in the midst of what I call the precision revolution, in which we are basically interested in not only improving numbers of therapies and interventions that can be easily offered to patients, but to increase the efficiency with which those offerings are provided to patients and to improve outcomes. Because frankly, one of the major problems that we face in medicine is that some of it is trial and error. And so precision medicine helps to cut down on that trial and error aspects of care and make it to where you hit the bullseye every time that you make an intervention. That requires understanding of the individual and the differences and similarities of that individual to other individuals and to populations. And it's this level of integrated knowledge that actually helps the provider make good judgments about what the best course of action is in trying to correct disease. And it's the combination of environmental influences, lifestyle choices and determinants with genetics and genomic insight that together provide the platform that we now recognize as precision medicine. The delivery of that care can be manifested in many different ways. You could have advances which are at the level of digital resolution of medical imaging. It could be at the level of wearable devices that people utilize to, gather the information. Or it could be at the level of, improved inhalers for people who have, asthma and problems of that sort. But all of those advances benefit tremendously from the information and the knowledge that originates from genetics and genomic interventions. New technology is now becoming available that allows for pretty exquisite genetic manipulation in ways that will allow us to improve upon gene therapy approaches and optimize the way in which we utilize the technology to bring improvements in quality of care for populations. Another important dimension to this is the fact that while in the past we tended to think of genetics and genomics as fancy, expensive interventions, the reality is that the cost of genetics and genomics clinical interventions is dropping down exponentially, and that these are going to become tools that can be easily integrated into primary care, into public health interventions, and into modalities that can actually be integrated into day-to-day life. And I think the future is extremely exciting in terms of that and our ability to sort of capitalize on those advances to improve the health of our society.
Coming up next, we've got an interview with Dr. Maurice Godfrey, ASHG Chair of the Public Education and Awareness Committee, where we discuss the importance of engaging the public about human genetics and genomics. First, though, let's head to Nigeria to look at 54Gene, a health technology company tackling the disparity in precision medicine by building one of the world's richest data sets from the most genetically diverse populations in the world, Africa, and applying deep analytics to derive key insights from this unique data set.
I wanted to bring drugs that could treat Africans and the global population, and I wanted to do a lot of the work in Africa.
When we talk about individualized treatment, you actually need to have a much more diverse data set to work from. And that's really where inclusion of the African population in genomics research helps to do that.
We have built some of the best sequencing facilities in Africa. We have also just commenced our work into drug discovery with a new translational biology group.
Working with physician researchers and genomics researchers that understand the people and the community in which we are conducting our research studies, I think is critical for building trust.
We're very interested in moving into novel ethno-linguistic groups to integrate all those findings into a therapeutic discovery pipeline that can identify novel treatments that will benefit these populations and, by extension, the global community.
Now over to the United Kingdom. The Centre for Personalised Medicine is a partnership between the University of Oxford's Wellcome Centre for Human Genetics and St Anne's College, Oxford. It is a communication and engagement vehicle for students, academics, clinicians, and the public to explore the benefits and challenges of personalised medicine.
Personalised or precision medicine is a broad field that aims to use what we can measure about individuals to inform their healthcare.
In order to do so effectively, we really need to pay attention to the ethical, legal and societal aspects that are involved in implementing those exciting advances in practice.
We see the links to the wider social issues to which personalised medicine gives rise as being absolutely central to our efforts. The Oxford Centre for Personalised Medicine was formed in 2013 to engage and communicate with scientists, students and wider publics, and to address a widening gap between the advancing science and the application and practice of personalised medicine. We've engaged with and held events involving researchers in many different fields, including law, economics, bioethics, demography and palliative care.
The Centre have also been working together with school children, inspiring an early interest in science and medicine.
We are always seeking innovative ways to engage.
The Centre for Personalised Medicine really brings in a lot of diverse disciplines and expertise to look at the whole picture about personalising medicine.
ESR is New Zealand's crown research institute that specialises in science relating to people and communities, unlocking the voices in the community on how they see genomics working for them.
ASR works across a number of science domains, from public health to environmental science, which includes water purity and food safety, into radiation and forensic science. And the important thing is the overlap of these sciences to give us different types and different perspectives on new ideas that are coming out.
Genomics has played a huge role in Aotearoa, New Zealand in the COVID response. So we have been fortunate enough so far to have a small number of cases, and so the team at ESR have managed to, in recent times, sequence over 90% of the cases.
When it comes to human genomics, it's really important to recognize the rich culture and history our indigenous populations have around DNA, because for us it's a biological molecule, but for them it's so much more. It's about their environment, their history and their futures.
ESR can support Māori communities by getting closer to Māori communities, understanding their views, their worldview and the way in which they would like to utilise the utility of our science capability. It is important that the science fraternity understand that working alongside Indigenous cultures and their knowledge sets is key in exploring knowledge at its highest level.
You can find ASHG TV on the front page of the meeting platform, where you can browse through the playlist to watch full-length versions of all the content featured in our daily show. We are also hosted on a dedicated page on the ASHG website and on our YouTube channel and Twitter. For the latest news and developments in human genetics and genomics, visit ashg.org. Now, I am delighted to be joined by Dr. Maurice Godfrey. Dr. Godfrey, thank you so much for your time today. So what is the ASHG doing to engage the public about genetics and genomics?
We do that in a number of ways, including having public seminars that engage people across the world, really, with webinars about genetics and genomics. And when we have in-person meetings, which obviously we haven't had the last couple of years, we are able to bring in local people to wherever we're having our meetings, or we go out to the public in different cities.
And why is it important that we engage the public with this science?
It's really important for the scientific community, for societies like ASHG, to be on the forefront of making sure that the public is aware of real and accurate and true information. We've all become acutely aware of the importance of accurate and correct information to the public.
How is the Public Education Awareness Committee implementing new approaches to expand the reach of its educational activities?
Reaching all populations and gaining trust from multiple populations is very important, and we need to learn, and that's what we're doing as a Public Education and Awareness Committee, is learning from different communities. What do we need to do? Where do we need to be to do build the proper trust to be able to, in the future, bring modern, personalized medical care to all communities?
And how do you ensure that you communicate the value of genetics to the wider audience, especially those underserved populations?
We have to learn the specifics and be in the community. That's the most important thing. It's not the society or the scientists from on high preaching, but it's going into the communities and learning from the communities and building that trust from the ground up, and approach them in a respectful and open way. And I think that's what's going to be happening, what has been happening over the last number of years.
How can members get involved in ASHG's diverse public engagement programs?
We very much would love for the broad support from membership to be engaged in a lot of the public education activities that go on. One of our annual programs is the DNA Day Essay Contest, and the Society puts out a call for judges to read essays from high school students from all over the world in responding to a particular question, and the question changes every year. The other thing that's important, again, for members to volunteer for the GENE Network, the Genetics Engagement Education Network. The public can come, schools, community groups, can find people, geneticists from ASHG, to come and present at local events.
What is the vision of making human genetics and genomics truly equitable?
We are much more alike as two individual people than we are different. And it's important for that lesson to be learned by everyone. And that's something that the society, the Public Education and Awareness Committee really wants the public to know. So knowing the basis of we're so similar, yet these individual differences may make an important distinction when it comes to medical care, and knowing that we as professional geneticists are trying to learn everything that we can so we can provide in the future the best possible genetic medical care to people.
Dr. Godfrey, thank you so much once again for your time today. We appreciate it. The Cardiovascular Genetics team at Texas Children's Hospital includes experts in both common and rare hereditary heart diseases. The genetic counselors, cardiologists, and PAs are building a community amongst affected families and building a research program that will change patients' lives.
My name is Zoe Shiner, and I was diagnosed with CPVT. CPVT is genetic, and it runs on my mom's side, and my mom's mom had passed away, and my mom is currently in a nursing home, and she is unresponsive. And I was early enough to catch it when I was 13.
Within cardiology, there's lots of kinds of genetic disorders that can occur. The 4 that we really focus on within cardiology are heritable aortic disease, which some people call aortopathy, congenital heart disease, which is caused by genetic disorders, genetic arrhythmias, and also cardiomyopathy.
The goal of the genetic counselors here is to help our families understand, cope with, and adapt to living with a genetic cardiac diagnosis.
I could not imagine life without the Cardiovascular Genetics program.
For our final stop, let's head to Newfoundland and Labrador in Canada to take a look at Sequence Bio, a biotechnology company combining multi-omic population data and longitudinal health records from Newfoundland's founder population to discover novel drug targets that power life-changing medicines.
Better drug targets are the master key to new medicines in areas of unmet medical need. It is a globally important goal that we believe is best accomplished with a founder effect, a naturally occurring competitive advantage for discovery occurring in Newfoundland and Labrador.
Because the founder effect improves the power to discover by 10 to 170-fold for minor allele frequencies, that means we can make smaller cohorts, assemble them faster, for less money, and identify far fewer false positives in the discovery regime. We believe a multimodal approach is important. It's a systems biology approach. We work with our clients in pharma and biotech to create discovery cohorts exactly to their specification across a broad range of disease indications, both common and rare diseases. We intend to work with the entire populace and really help meet unmet medical need around the world.
That's it for the second episode of ASHG TV. We hope you will join us tomorrow for the final episode where we will look at new science and innovation in genetics and genomics and learn how ASHG is inspiring the next generation of educators and mentors within the field. Don't forget, you can find us on the front page of the meeting platform, as well as on our YouTube channel and Twitter feed. Thanks so much for joining us. We will see you right back here tomorrow.